Hello students, welcome to DSE Super 20. In this video, we are going to look at the DSE 2021 paper, and in the 2021 paper, we are going to look at the micro questions 26 through 30. Okay, so let's start with question number 26. So in question number 26, there's this cinema, ABC Cinemas, which is the monopolist in a town. The demand to see a movie is given by this equation in the afternoon and this equation in the evening. P denotes the price of ticket. Movie distributor charges ₹4 per ticket sold to the ABC Cinemas. So right now the thing is that distributor is charging a royalty fees of ₹4 per ticket sold. Now, instead of this, suppose the distributor asks the ABC Cinemas to pay a flat fee of ₹X to show the movie with no charge per customer. Find the value of X such that ABC Cinemas will be indifferent between the current pay per ticket contract and the fixed pay contract. So basically, we have to find the profit which this person makes right now, and then if the fixed marginal cost of royalty is removed, then what is going to be the profit? So the difference in profit in the first case and the second case is the amount which this person will be willing to pay as a fixed one-time charge. Okay, so in order to do that, what we'll do is we'll just write down the profit function of this particular firm. So profit, initial case mein profit is equals to price A, price of afternoon, minus 4 into quantity in afternoon, plus price of evening minus 4 into quantity which he sells in evening. So QA and Q, this is QA and this is QE, right? So when I substitute these values, it's going to be PA minus 4 into 100 minus 10 PA plus PE minus 4 into 200 minus 10 PE, right? So I'm just going to differentiate with respect to PA and PE. So del pi by del PA is equals to 100 minus 10 PA minus 10 times PA minus 4, which needs to be equal to 0. So when you solve this, you just get PA must be equal to 140 by 20, which is equal to 7. So this is the afternoon ticket price. Similarly, del pi by del PE will turn out to be 200 minus 10 PE minus 10 times PE minus 4, which must be equal to 0. So when you solve this, you get P in the evening must be equal to 12. So you have PA and PE values. You can substitute it back into the profit condition which was here. Okay, so you just substitute PA and PE in this original equation or this equation. So what you will get is that the initial profit pi naught will turn out to be 3 times 100 minus 70 plus 8 times 200 minus 120. So this is equal to 730. Okay. Now in the second part, what we'll do is we'll repeat the similar process, but instead of PA minus 4 and PE minus 4, what we will do is just pi prime is equals to PA and PE. Okay. So we are going to solve this particular set of equations. So when we do del pi prime by del PA, the equation we get for this is going to be 100 minus 20 PA is equals to 0. So this just gives me PA prime must be equal to 5, right? And similarly, del pi prime by del PE जब मैं करता हूँ, so the equation I would be getting is del pi prime by del PE is 200 minus 20 PE is equals to 0, which implies PE prime must be equal to 10. Alright, so initial prices were PA equals to 7 and PE is equals to 12. So now the prices have gone down because you don't have to pay a royalty fees anymore. So let's try to find the profit. Pi prime is equals to 5 into 50 plus, just substitute into this equation, right? So substitute into this equation. So 5 into 50 plus 10 into 100. So that becomes equal to 1250. So what is the difference between these two? So 1250 minus 700. So the difference is 520. So that is your answer. Okay. All right. Let's move to question number 27. So in an exchange economy, there are two goods X and Y, two agents A, B. A owns 10 units of good Y, whereas B owns 10 units of good X. Okay. So endowment of A is equals to 0, 10, and endowment of B is equals to 10, 0. Okay. After this, they have given the definition of lexicographic preferences. So utility of A is equals to lexicographically preferring good X. Utility of B is equals to lexicographically preferring good Y. So choose the correct answer from the options below. So there are two statements. An allocation where A gets 10 units of good X and B gets 10 units of good Y is Pareto optimal. Okay. So A likes, so in this case, this is my Edgeworth box. Construct the Edgeworth box. So this is my Edgeworth box. This is 0, 0. This is 10, 10. So in this case, we know that the set of Pareto optimal allocations are the bottom and right edges. And because this corner point lies on this on this section, this highlighted section, it is in fact Pareto efficient. So yes, this point is Pareto efficient. The second is the allocation where A gets 10 units of good X, 5 units of good Y, where B gets 5 units of good Y is Pareto optimal. So that is this point. So this point is also Pareto efficient. So all these points are Pareto efficient in this particular case. Okay. So if you want to know how we get the contract curve, you can watch our video on exchange economy. You can find the video on YouTube, or you can install our application, and I'll be happy to guide you how to get access to this video and all the other videos that we have. All right. Now let's move to question number 28. Which of the following assumptions is not required for the first welfare theorem in exchange economy? Okay, so the first welfare theorem के लिए मुझको इनमें से कौन सी चीज़ें नहीं required है? So absence of externalities is a precursor, right? Monotonic preferences is also required, and the third one is the first option, well-defined property rights. So well-defined property rights जब नहीं होते हैं, that is when externalities rise. Actually, these options 1 and 2 are one and the same. Whenever property rights are defined, externalities cease to exist. That is Coase theorem. Okay, so you can just Google Coase theorem. So Coase theorem says कि so externality क्या है? जैसे pollution है. So externality is nobody has property right over atmosphere. It is a public good. So that's why anybody can pollute it. Had somebody owned this public good, which is called as atmosphere, then that person would fine you. You are polluting my property, so pay me. So because there are no property rights defined over public goods, that is why externalities exist. Okay, and so options 1, 2 and 3. 3 is again monotonic preferences. It just says ki if you increase the amount of all goods, the utility will increase. So these 3 are definitely required. convex preferences are not required. Okay, you don't need convex preferences in order to for the first welfare theorem to be applicable in exchange economy. Okay, now let's move to question number 29th. So in question number 29, this is game theory in which people are donating some money. So everybody has a budget of 200 and they give money to a charity. If the charity is able to collect at least 100 rupees from these two people, it will do something good to the economy, and that will give a utility of 60 rupees to each of these people. Okay, so if total donation crosses this threshold of 100, their utility is whatever is money they are left with plus the altruism utility which they get because of this work has taken place. Otherwise, the excess rupees which they donate goes down the drain. It just reduces their utility. Okay. So in this case, which of the following is true? So in this case, if I want to find Nash equilibria, there are multiple Nash equilibria. One is x comma y is equals to 50 comma 50. This is one very simple Nash equilibrium. Both people are spending 50 rupees. So as you can see, nobody has an incentive to deviate. What is Nash equilibrium? The most important thing for this exam which you need to remember about Nash equilibrium is that Nash equilibrium is no incentive to deviate. So that strategy profile from which no person has an incentive to deviate. So suppose I consider this particular strategy profile where everybody is donating, both the people are donating 50 rupees each. So does somebody have an incentive to deviate from this point? Okay. So if person 1 increases donation, it's not going to cause, because if he increases x, this x increases, so overall utility reduces, because the project is anyway going to be taken up right now. 100 rupees donate ho raha hai. So by increasing donation, nobody has an incentive to deviate, and by reducing donation, if anybody reduces their quantum of donation, the project does not get constructed. So by reducing donation, again they are going to reduce their utility. So from this point, nobody has an incentive to deviate. Okay, but the question is it the only Nash equilibrium? No. There is another Nash equilibrium as well. X bar y star is equals to 45 comma 55. So even in this case, nobody has an incentive to deviate. Total is still 100, right? So the project gets undertaken. So if you write down the utility of both these people, they are both highest possible. So if anybody now increases or reduces their individual contribution, their utilities would fall. Similarly, 55 comma 45. In fact, any x comma y such that x plus y is equals to 100 is a Nash equilibrium in this case. Any xy combination where x plus y is exactly 100 and x y individually less than equals to 60. ठीक है, दोनों को individually 60 से कम होना पड़ेगा, because 60 is the benefit they get. So you can have combinations like 41 59, 42 58, 45 55, and vice versa as well. All those are possible Nash equilibria. Okay, so all such Nash equilibria exist. So the game has multiple Nash equilibria where the aggregate donation is rupees 100. Okay. Alright, let's look at question number 30 now. This is the last question from the microeconomics part. Again, an extension of the same question. Now he's asking me which of these is not true, which of these is false. So each player has at least one weakly dominated strategy. So yes, there is one weakly dominated strategy, that is to donate 100 rupees, right? So if you donate 100 rupees, that is weakly dominated by every other strategy actually. Okay, if you donate 100 rupees yourself, or 200 rupees for that matter. Okay, so donating 200 rupees, you are left with nothing. You are left with negative with just 60 units of utility. So that is weakly dominated by donating, let's say, 100 rupees. Okay, So donating 200 is weakly dominated by each and every strategy. Okay, so this is true. Okay, x comma y, x is equals to 200 or y equals to 200. These are both individuals weakly dominated strategies. Strictly dominated strategy, again same one. जो स्ट्रिक्टली ये एक्चुअली स्ट्रिक्टली डोमिनेटेड है, जो स्ट्रिक्टली डोमिनेटेड है वो वीकली भी डोमिनेटेड है, बिकॉज वीकली डोमिनेटेड स्ट्रैटेजीज आर अ सुपर सेट ऑफ स्ट्रिक्टली डोमिनेटेड स्ट्रैटेजीज. ठीक है. Now third one, each player has a strategy which weakly dominates all other strategies. Now this is false. Why is this false? Because so this one is false, because in this case what he's saying is that there's some strategy which weakly dominates all other strategies irrespective of what the other guy does. So that's not true. You have to think about what the other guy is doing. So if the other guy is donating 50 rupees, if y, so best response of player 1 for y equals to 50 is equals to 50, whereas best response of player 1 for y equals to 60 is equals to 40. Best response of player 1 for y equals to 0 is 0. So your best response keeps on changing depending on what the other guy is doing. If the other guy is not donating anything, it doesn't make sense for you to contribute everything. तुम 100 रुपये दे के वो ब्रिज या जो भी चीज़ बन रहा है वो बनवाओगे नहीं, because that utility of that particular project is only 60 units. You pay 100 units for it, doesn't make sense, right? So your best response keeps on changing depending on what the other guy does. So that's why there is no weakly dominant strategy. So this is false. And fourth one is maximum payoff of each player is 200. So maximum is where you maximize the minimum possible outcome. So maximum payoff. So this is again true. The maximum. So suppose, so this is a very pessimistic sort of approach towards game theory. So maximum is probably something you have never heard of. So I'll talk about in a bit in a couple of minutes. So maximum is you don't trust the other guy. You feel that the other guy is out there to hurt you. So you want to choose a strategy which maximizes the minimum possible payoff that you can have. ठीक है. So तुम सोच रहे हो कि दूसरा आदमी तुम्हारा बुरा ही करने वाला है. So what you do is, in that case you donate nothing. So when you donate nothing, what happens is या तो ब्रिज बन जाएगा या नहीं बनेगा. बन गया तो अच्छा, if that project happens, good. If it doesn't happen, you have your 200 rupees with you. So that is 200. For any other sort of donation, for example donating 10 rupees or 20 rupees, there is a possibility. Suppose you take x equals to 10. For example, suppose you decide to donate x equals to 10. So now if the other guy chooses y equals to 0, your utility is just 190. So the minima possible now is 190. Suppose you donate 50 rupees and the other guy donates 0, your utility is just 150. तुमने 50 rupees donate कर दिया, the project doesn't happen, so you are left with just 150 rupees, so your utility is reducing. So the maximum thing here is you donate nothing, so that the worst case possible is maximized. The worst case possible is maximized. So that is maximum. Now ideally maximum is something which they have asked for the first time. So if you have not heard of it, maybe you can Google it. But the thing is, in this question you don't need to know about maximum in order to solve it. If you can be sure that the third option is false, you don't need maximum at all. So you can just proceed to mark the option here. So in such questions, this happens a lot. A lot of times what DSE does is it asks you the true or false statement. It gives you 4 statements. जिसमें से एक statement is you have never heard of it कि कहाँ से आ गया. Okay, but in that situation बाकी तीनों को solve करके आंसर मिल जाएगा. अगर ये तीनों true निकल जाते, then irrespective of what the fourth thing is, it had to be false. right? So even if you know 3 of these things, you should attempt the problem. So this is a pattern which I have seen with DSE happen a lot of times. Okay. All right. So thank you for watching this video. Please subscribe to our channel, and if you give like this video. If you like this content, please like and also install our application if you want mock tests or any other free content. Also, we have a lot of courses available. So thank you guys.